In this lecture, we will learn about arrays in C#. Instead of having to create a separate variable to store each value in our program, we can store one variable that holds a sequence of values. This is the purpose of using an array in our program. There are two types of collections in C#, linear and nonlinear. Linear means that the collection stores its values in some sort of sequence. Nonlinear means that the elements are not stored in any particular order. Arrays are a linear data structure. Their elements are stored in a sequence. Let's look at an example of creating a string array of length 3, meaning that our array will have the capacity to hold 3 elements. There are 4 ways that we can create an array in C#. The first way is as follows. First, we specify the type of variable that the array will store, and then have an opening and closing square bracket following the type. We will name our string array strings. Let's set our strings array equal to a new string array of length 3. The new keyword comes first, and then string, the type of variable that the array will store. Inside of the square brackets comes the size of the array, which will be 3. The second way that we can create an array is to also specify the values that will populate the 3 slots. To do this, after we specify the size of the array in square brackets, we can use curly braces, inside of which will come a comma-separated list of values. For example, we can populate our array with the string values A, B, and C respectively. The third way to create an array is to do what we just did, but not include the size of the array between the square brackets. Based on the number of elements that we included, the compiler understands what the size of the array is. Believe it or not, the fourth way that we can create an array allows us to omit the new keyword and directly supply the values for the array inside of curly braces. One key point to note with this fourth way to create an array is that if we declare the array and then initialize it later, we need to use the new keyword. For example, say we have a string array named strings that we include at the top of the class. Then, later on in the program, we would need to use the new keyword when we tried to set the values of the array. Note that if we attempt to just supply the values, this will cause an error. This is considered invalid syntax, since the declaration and assignment of the array is occurring at 2 different places in the code. The new keyword is required for the assignment to be valid. Here is another example of initializing a single-dimensional array. This time it will be an array of integers. As we learned, we can also specify the contents of the array on initialization, and then the size of the array will be the amount of elements we specified by default. Here's an example of specifying an array of integers 1, 2, and 3. Okay, let's take a moment to understand how these values are stored in memory. 1, 2, and 3 are sequential in the array, and are stored in contiguous blocks of memory. The element 1 is stored at index 0 in the array. Indexing in C# starts at 0. The element 2 is stored at index 1 in the array. The element 3 is stored at index 2 in the array. We can access an array element by referencing the index number. Let's first make sure that we import system.diagnostics at the top of our program, so that we have the ability to log information to the Visual Studio output window using the debug class. Then let's say we want to print the element at index 0 to the output window. We would use debug.writeLine and then pass in the name of the array, which is array. Then we will use square brackets. Inside of the square brackets comes the index that we want to reference, which is 0 in this case. This syntax will give us the element in our array at index 0. Then we will run the code. As you can see, 1 was printed to the output window. To change the value of an element, we can use the index and assign a new value for the element at that index. For example, we can use index 0 and change the value of the array at index 0 to 5. If you want to obtain the length of an array, you can use the length property. The array class has a sort method that will sort the elements in an array. Using this method, the array will be sorted in ascending numerical order if it is an array of integers, and alphabetical order if it is an array of strings. Let's look at an example of sorting an array of integers. First, we will use the sort method to sort the values in the array. Since this is an array of integers, sort will put them in ascending numerical order. Then we can use a for each loop to iterate over each value and log it to the output window. Arrays implement the IEnumerable interface, so you can use for each iterations on all arrays. As you can see, The 5 was moved to the last element in the array since it was the greatest of the values. The 2 and the 3 were already in order before we called the sort method. Now let's take a look at an example of sorting an array of strings. First, we will create a variable named array of type string array and initialize it to a new string array with the values C, A, and B. Then we will sort the array using the array class's sort method and passing in the array. We can use a for each loop to iterate over each string in the array and log it to the output window. As you can see, the array was sorted and is now in order with the elements A, B, and C in alphabetical order. Array elements can be of any type, including the array type. Arrays derive from the abstract array class. To get a deeper understanding of arrays, let's type system.array inside of the code, and then select the word array, right-click, and choose Go to Definition. This will take us to the public abstract class array, which all arrays derive from. All arrays implement the interfaces we see here. An array has all of the properties we see here, and implements all of these methods. The interfaces that an array implements are iClonable, iList, iCollection, iEnumerable, iStructural Comparable, and iStructural Equatable. If we want to dive deeper into any of these interfaces, we can select the interface, right-click, and choose Go to Definition. This will show us the details of that interface. I highly suggest that you not only do this for the array class, but for all of the different data structures that we learned about, so that you can get a deeper understanding of them. For your convenience, I will summarize each of the interfaces for you. The iClonable interface supports cloning, which allows the array class to be cloned into a new instance of the array as an existing array. iList is an interface that represents a non-generic collection of objects that can be individually accessed by index. It makes it possible for us to use indices with arrays to be able to reference elements and change their value using their index. The iCollection interface defines the size, enumerators, and synchronization methods for the array. The iEnumerable interface allows us to iterate over elements of the array using programming constructs like the for and for each loop. iStructural Comparable gives the array the ability to compare a collection of objects. This lets us do things such as sort the elements of the array. The iStructural Equatable interface lets us compare the array elements for equality. In the next lecture, we will learn about lists in C#.